Hello, everybody. I hope you can all hear me well. My name is Chiara Benetti. I work for IEA Florence Renewable Energies, based in Florence, Italy. And today I will introduce IEA Bioenergy Webinar on potential for cost reduction. The webinar will be presented by Adam Brown from Energy Insights UK. After Adam Brown's presentation, the webinar will be followed by a Q&A session moderated by Luke Feldmans, Technical Coordinator at IEA Bioenergy. This session will have as panelists Lars Valtheim from Valtheim Consulting, Sweden, Ingvar Landahl, Fuel and Energy Consulting, Sweden, and Jack Sadler and Mahmoud Ebadian from the University of British Columbia, Canada, representing also IEA Bioenergy Task 39. I would like to remind you that during the webinar, you will have the possibility to type questions in the Q&A pod at the bottom of your screen. Our panelists will reply to the questions either by typing the answers directly in the pod or at the end of Adam Brown's presentation during the Q&A session. That's all for now. I will pass now to Adam Brown for his presentation. So enjoy the webinar and thank you for your great participation.
Okay, so this is Adam Brown. I hope you can see the slides. Thank you very much for joining us this afternoon. It's good to see we have so many people joining. Either it's a very interesting report, you think, or alternatively, there's nothing very much on Netflix if you're confined like many of us are. So anyway, I hope you can see the screen. So I'm going to do this brief introduction to the report that we prepared. The report was published at the start of this year. And then my colleagues will do the difficult bit and answer your questions later on. So first of all, a little bit about the study. The team who worked on this, first of all, we had Lars and Ingvar who were online today. They were the authors of an earlier report on the costs of advanced biofuels, which was published under the special group on advanced biofuels or something like that in 2017. So they were on to use the same methodology and for continuity. I helped out particularly with the benchmarking part of this to say how does this compare with current and future fuel prices. We had from Task 39, we had Jack and Mahmoud who are online today, along with Jim McMillan, who's at NREL. And we also had a connection with Brazil with Antonia Bonomi and Bruno Klein, who were at CNPM when we did this study. So that was the team. And the idea was to build on the work that Lars and Ingvar had done before, but also to broaden the scope a bit geographically. So this project was a project under IEA Bioenergy, under Task 41, which deals with sort of special projects like this. And it was made possible by funding from the European Commission, organised by Kyriakos Maniatis for us, with in-kind contributions from Sweden, Netherlands and Germany, who provided comments and inputs into the report. as I said before, the idea of this was to take this report, which was done in 2017 by Ingvar and Lars and some collaborators, which had a first look at the costs of a range of advanced biofuels. So we wanted to take this, and if we could extend the scope of that by getting into some additional technologies, and also by getting contributions to that from a broader geographical area. The second thing we wanted to do then was to look at those costs that came from the current costs that we identified in the report, and then to say to industry and others, okay, well, what do you think is the scope for being able to reduce these costs in the short term, because from what you've learned from existing projects and so on and so forth, and further into the future. And then to compare these costs and the likely trends in costs with what fossil fuel prices, the range of fossil fuel prices today, and those that you can imagine might come in the future. And, oops, it's going the wrong way. And also look at how these compare with some of the more conventional biofuels like ethanol and biodiesel. And then lastly, to look at what the policy impact of this is. If we're going to have advanced biofuels, what are the policy implications for that? And particularly, is there a cost gap which policies will need to bridge? So that they were the main elements of the study as we carried it out. So the way we did this was, first of all, to go back to the people who'd contributed to the other study and to a range of other industry and other sources to get their information on what they thought the current costs of production of these advanced biofuels were and what they thought the scope for cost reduction was. To normalise and rationalise that data, to put it on a common basis, and to look at how the various elements, the capital, the operation and maintenance costs, and the feedstock costs contributed to the final product cost for the range of fuels that we were looking at. And then to look at the scope for cost reduction, first of all, by saying to industry, look, if you could build a short series of plants over the next 5 to 10 years, what do you think would be the scope for bringing down the costs through measures that you're already thinking about now? Secondly, as you go forward and these technologies become more widely deployed and therefore are perceived as less risky, it should be possible to finance the projects under more favourable financing conditions, and that will bring the cost down. And then thirdly, to look at what would happen to costs if you had massive deployment of the technologies. As you'll see later in things like the IEA Bioenergy Roadmap, which I was involved in 2017, that imagines that in the long run you'll have very extensive rollout of advanced biofuels, and that ought to provide opportunities to bring the cost down even further. And we tried to find out what that in fact was. And then we looked at how these numbers compared with fossil fuel price scenarios with and without policy support. Now the value of this report to some extent depends on us getting information from industry. We tried our best to spread the net as wide as we could. You can see here we contacted nearly 90 companies and asked them to fill in a questionnaire about what their current expectations of costs were, and then also how these costs might come down. We actually had substantive responses from about 22 companies. Some didn't respond, some gave us some information, but there were just over 20 who gave us really solid information, either commenting on the costs which were in the earlier report or new information that we were able to use. You know, obviously some of these numbers are commercially sensitive. We can understand that the companies are nervous about what they want to tell us. We did provide assurance that we wouldn't publish numbers for individual companies or for individual processes without telling companies what we were going to do. And you'll see, if you look at the report, that we've come up with ranges of costs which cover a number of different inputs for each different technology. Oops, what have I done now? Before we get into the results, a question about units. Units is the units are a difficult question for when you're doing this. Everybody has their favorite units they want to use. The default energy unit we use throughout the report is megawatt hours. First of all, this was the unit used in the earlier study, and we wanted to have consistent with that. I think it's also very important to have an energy unit, not a fuel-based unit, or a volume-based unit, because actually otherwise you're talking about different bases for doing things. You can see a megawatt hour is 3.6 gigajoules, 0.086 tons of oil equivalent, or 3.41 MBTU. I'm sure everybody will have their own units they would like to have seen this report in, but we have to standardize. Here are some equivalents if you want to think about litres of ethanol, gasoline, and it always keeps jumping about like this, and diesel. Again, we talked about the energy content as in megawatt hours per ton of material. There's about 5 megawatt hours in a ton of dry biomass. You can see at the back of the report, if you're confused by all that, you can see in the back of the report we've put in quite a lot of conversion things you can look at. So here's a summary of the work we did to look at the current cost estimates of the range of biofuels. You can see across the bottom the range of fuels that we looked at: cellulosic ethanol. We also looked at a sort of halfway house where you integrate cellulosic ethanol production with conventional corn ethanol production. We have methanol and methane from biomass and from wastes. The same for Fischer-Tropsch liquids, and then bio-oil co-processing, both in standalone and in co-processing mode, and also HVO and anaerobic digestion. And you can see for each of those, there's a high and a low estimate, which is quite a big spread in most cases. And for each of them, we've estimated the contribution to the final costs in terms of the feedstock, the capital, and the operating costs on a sort of normalized basis. You can see, if you look in the report, you can see the more detailed breakdown of all that. If we look at that in another way, if we just look at the ranges, you can see there's quite a big difference between the different the ranges of the different biofuels. Cellulosic ethanol's a bit on the high side. Some of the others, like bioethanol and methane, are quite a bit lower. You'll see that the waste-based fuels from methanol and methane and FT liquids are significantly lower than the costs of the biomass-based things, just because the feedstock is a significant influence on the cost, and the feedstock costs are much lower, and in the waste case, sometimes negative. And here you've got the relative cost price for a range of current fossil fuel prices. We took there a range of $40 to $70 a barrel. We looked at at how the prices of diesel fuel and other fuels that are biofuels would be directly competitive. Compared with those, there's a a markup compared with those, and then we converted it into these units. Now, we've already had some questions about what the impact of the fall in oil prices would be. You can see that with oil prices in the Brent crude is around $20 a barrel today. And I think in the US it's minus 20 something dollars a barrel. So you can see that the lower the oil price goes, the bigger the gap becomes between the fossil fuel price range and our estimates of the current costs. You can see in most cases there is a gap. The advanced biofuel estimates are significantly higher than the fossil fuel price range, except for where you've got waste-based fuels. Then we looked at the scope for cost reduction in the medium term. This is what people could do, making changes to the process that they felt confident that they would be able to implement and bring the cost down. And we quite a range of different cost reduction numbers we got from talking to industry and from other sources. The range of potential capital cost reductions was higher for cellulosic ethanol, between 20 and 50%, and about 10 to 20% for the thermal processes. This is largely because a lot of the unit processes within the thermal processes are already quite widely used elsewhere, and probably less scope for cost reduction than in the cellulosic ethanol case. The operating cost reduction potential was estimated to be 10 to 20%. The fuel price component is very significant in this. We assumed in our calculations that actually we wouldn't get the same levels of reduction in the fuel part of this. It's a complicated discussion about what might happen to fuel costs. You can see how for some specific fuel supply chains, there might be efficiencies you can imagine which would help bring the cost down. But then as you start fishing in a bigger pool, as capacity goes up, then actually it might be hard to find very low cost feedstock costs. And in the long run, you might imagine feedstock costs going up. So we struggled a little bit with that, and we decided in our estimates of cost reduction for the moment, we would leave that constant. We also looked at the reduction in capital cost charges. If you go from a financing regime of 10% over a 15-year lifetime to 8% over a 20-year lifetime, that we looked just to see what the sensitivity to the capital regime was. And here you can see the results of that. You can see the blue bars for each of the technologies is the range of the current costs that I showed you earlier. The red bars show the technical impact of the technical changes that we felt could be made. And then the green bar adds to that some impact of the lower financing costs. And you can see the costs are projected to come down quite significantly, between 10 and 27% because of the changes in the capital and operating costs, and a further 5 to 16% on the capital charges. It depends on the ratio of the capital element to that of the operating and maintenance costs and the fuel costs, what the impact is. And again, you can see under these circumstances, when you've really got those costs down, then at least the waste-based technologies are starting to be within the fossil fuel price range that we used. Then we wanted to look at the impact of over a longer term, what the potential for cost reduction could be in the longer term. This is inevitably a bit more speculative. As I mentioned before, if you look at a lot of low carbon energy scenarios, then advanced biofuels play a big role. in the IEA's roadmap, which is based on the IEA's 2DS scenario that was done in 2017. You need something like 4,000 large-scale plants to provide the 25 exajoules of advanced biofuels that are needed in that, particularly to help decarbonize the transport sector. So these scenarios imply a very huge scale-up, increasing deployment of these technologies. So in order to look at the impact of that, we used a learning curve approach. If you're not familiar with learning curves, then this is a technique that's been used in a lot of different industries. If you look at the production costs of a whole range of different products, including chemicals and so on and so forth, you find that as production volumes go up, the costs come down, and it they come down in a sort of logarithmic basis that for each doubling of cumulative production, you get a certain % learning rate. This isn't hard physics. This is just an empirical observation that goes across a very, very wide range of technologies and products. And so we decided to use this. You can see the sort of impact here that you get as you increase the cumulative production by a factor of 10, and then 100 and 1,000 for different learning rates. So the top rate says that every time we double production, we get a 5% reduction in costs. So this learning rate stuff does actually have quite a significant impact on costs. If, for example, you look at photovoltaics, right back to when solar photovoltaics were first introduced, they followed very closely a learning curve like this with something like a 21% learning rate. We look to try and find a suitable rate for technologies like this. We found some references to rates like 20% for ethanol in Brazil, for example, but it's very hard to be specific about what learning rate you'll actually get, because it depends to what extent you're talking about really new technologies and to what extent you're talking about technologies which have been used widely elsewhere. So it's very hard to judge what's the appropriate learning rate. However, if you apply these learning rates to the costs I showed you before, when you'd already done the short-term cost reductions, and we took the middle of the range there, you can see that as you go up in scale 10 times or 100 times, and as you do that at different learning rates, then actually you can have quite a big impact on the costs of the product you make, assuming that the feedstock costs stay the same. You can see the scale of the reduction there. Now we wanted to compare these with not only with the range of fossil fuel prices today, but also to look forward a bit. So what we did, we took the numbers from the IEA's World Energy Outlook scenarios, where we have the three scenarios depending on the policy mix: the current policy scenario, the new policy scenario, and the sustainable development scenario. And within those scenarios, the IEA has some numbers for the oil costs. And you can see, not surprisingly, that in scenarios which don't constrain carbon emissions and don't constrain the use of oil, then oil prices stay quite high. But as you progressively squeeze that through going by, first of all, in the new policy scenario, applying all the measures which countries have said that they would like to do, and then in the sustainable development scenario, really aiming for a big impact on carbon emissions, you can see as you go on between those three scenarios that the projected oil price goes down as demand for oil will go down. But the scenarios also have assumptions about what carbon prices are associated with those. And you can see in the CPS scenario, there's a low level of carbon price, but that progressively increases as you go to the more carbon reducing scenarios. Now, the impact of that is that the gap gets reduced. Oops. So while for the oil prices, there's quite a big difference when you take account of the carbon price trends as well, then you've got a much lower difference between about 80 and 110 euros per megawatt hour. And these are the numbers we've used in the benchmarking exercise in the study. So here you can see, if we take our graph with the long-term cost reductions in, you can see that compared with current fossil fuel prices, it looks like some of the technologies will be competitive that, but if you look at the longer term view with what might happen to oil prices plus the impact of a carbon tax, then actually these technologies do start to look competitive with the range of policy measures which might be involved in those long term low carbon futures. Now, oops, at the moment there is a cost gap. This shows the cost gap between the prices of the fuels and the equivalent fossil fuel prices, and you can see there's a significant cost gap. From a policy perspective, if you want to see these technologies deployed, then you have to find a way of branching that, meeting that gap, of bridging that gap, either by providing some support for the new fuels, or alternatively by putting some carbon tax or other measure on the on conventional fuels. And just to show that, this shows the equivalent euro per ton of CO2 price that you would need to put in as you bring these fuels online. So you can see that if you had a carbon price of 100 euros a ton, then you would start to bring in quite a few of the technologies at a reasonable price. But if you wanted to get the more expensive of these fuels on the market, then that price would have to go up to 400 or more euros per ton of CO2, which is quite high. So that's the analysis, if you like, of the costs and the benchmarking. We also in the report look at a number of policy measures which are already being taken as ways of bringing these technologies into the market. First of all, the good news is that there are some fuels which are making their way in the market. Here we have the progression in the production of HVO over the last 15 years or so, and you can see that's actually gone up by very substantially, a growth rate of about 170% since 2007. And so you can see when technologies, when people are confident in the technologies and the policy and other factors mean you can sell these fuels profitably, then actually they will take off. The other technologies have not done that so far. One particular policy measure that we look at in the report is the low carbon fuel standard in California. You can see here the impact that that's had on the biofuels market and the other low carbon fuels in California between 2011 and 2018. You can see the renewable diesel market has gone up substantially, biomethane has gone up, and while ethanol has still been important there, that's actually being supplemented or by the range of the other low carbon fuels. Now, if you look at the support mechanism in more detail, you can see the level of support. This is some work that Mahmood did, I think. And you can see here how the price, the market value of, this is for cellulosic ethanol, in that market is made up with a contribution from the base fuel price, which is basically the gasoline price, the credit you get from the low carbon, from the RINs, and then the low carbon fuel standard premium. And you can see that in 2018, 60% of the market value of the fuel actually came from the market support. If you actually take this support value and convert that into what that is in terms of a carbon support price, you end up with a number of around 450 euros per tonne of carbon. So it's actually a high, quite a high support level. And when you look at actually other support levels that are around in different countries for new fuels which are at the start of their deployment process, that's not completely out of line. So policymakers have been prepared to put their hands in their pockets, or to put their hands in our pockets more properly, and provide high levels of support to these fuels to get them started and into the market. So it's not as though the current or projected costs of these fuels are completely beyond what policymakers are prepared to take on. Now, this report, of course, focused on the cost and the cost reduction potential. We should just highlight that, of course, that's not the only issue. I mean, these fuels are actually different. They have different energy contents. They have different requirements to be used. Some of these are drop-in fuels that can be just used in the same systems we use for transport fuels, but others will need some other investments. So there's a whole range of other issues to do with resource availability, to do with how easy it is for these fuels to access markets, to do with the infrastructure costs that would be associated with bringing these fuels into large-scale use. The different fuels have different greenhouse gas profiles, and also raise different social and other sustainability issues. So the costs, we think, is an important issue, but actually when you're really thinking about these fuels and their role in the future energy market, there are a whole range of other things that you have to give attention to. So just to sum up, the comparison, the estimates of the current costs of production of these fuels with fossil fuel prices at the moment suggests there's a significant cost gap, which, if you want to see these things in the market, has to be bridged rather. The scope for reducing these costs between 20 and 50% through technical advances and improving the financing regime, probably over the next 10 years, as if people were able to build a series of plants and learn from the experience of doing that. If you do that, then the cost gap will be narrowed, but will still be there to some extent for most of the pathways, except those which rely on very low cost feedstocks. In the longer term, there's probably very significant scope for further cost reduction, although it's difficult to be too precise about that because it depends on the nature of the technologies and many other factors. If that happened, then there are the prospects of these technologies becoming competitive in the context of anticipated future fossil and carbon prices. If we want to see these things playing a big role in the energy market, then there will need to be continuing policy support. First, we have to get through successfully get through the demonstration and technical and demonstrate technical confidence in these technologies, and that will need some help to get through the valley of death. And then in the long run, there will need to be some strong carbon price signals or other mechanisms for encouraging these fuels into the market. And then lastly, of course, this cost is an important issue, but as anybody working with biofuels knows, it's not the only issue. It's a complex subject with many issues that have to be looked at. In this report, we didn't go in too much detail into those, but they are, of course, being looked at in many other places. So I think I will stop there. I hope that's given you a flavour for what's in the report. I'm not able to go into enormous detail here, and I look forward very much to looking to your questions and seeing how we can respond to those. Thank you very much.
Okay. Thanks, Adam, for this nice presentation. My name is Luc Pelkmans. I'm technical coordinator of IEA Bioenergy. So I've been following the project also from the sideline, but it's quite interesting results. And I will moderate this Q&A session. So you will have seen that there is a Q&A. Well, you could type your questions in the Q&A. And we'll try to go through them one by one to give you the answers as we can do. Just as a start of the Q&A, I would just like to give the word to all the people that you haven't heard yet. So there's 4 co-authors which are now also available in the panel to answer questions. And I'll just go to the 4 co-authors. Just can you just say who you are, from which company, and how you contributed to this study? So maybe Lars first.
Okay, my name is Lars Waldheim. I'm a consultant, Waldheim Consulting from Sweden. I was, together with Ingvar, I was one of the authors of the first version of the cost of biofuels report for the subgroup of advanced biofuels a few years back. And so I've worked on the updating and mainly on the thermochemical parts of the report. So I'm happy to take your questions. Thank you.
Okay, thanks, Lars. Ingvar, can you say something?
Yes, hello everyone. My name is Ingvar Landell from Sweden. I have a background in, first of all, gasification, where I've been responsible for development of black liquor gasification here in Sweden. I've been heading the biofuels technology platform and participating there for quite a few years. And I was, as Lars said, co-author of the SGAB report, and therefore also asked to participate in this, let's call it update and broadening of the SGAB report.
Okay, thank you, Ingvar. Maybe next, Jack Sadler.
Thanks, Luke. So I'm Jack Sadler at University of British Columbia. I can see on the participants, I'm lucky enough to work with several of the people that are on the call just now from IEA Bioenergy Task 39, working with my colleague Jim McMillan from NREL. Mahmoud will indicate what he's contributed. What I think we did with the report is to cover some of the companies who were non-European. So if I look at the I see one of the questions is generation 1.5. So looking at some of the piggyback technologies where I think they're already being used commercially. And I think we also contributed to some of the policy aspects, because I think British Columbia is following California's lead, where we're using policies such as the low carbon fuel standard to bridge the gap. Over to you, Mahmoud.
Okay, hello everyone. My name is Mahmoud Abadian. I'm the coordinator of IEA Bioenergy Task 39, working with Jack and Jim. And for this report, as Jack mentioned that, so we distributed the project questionnaire among 25 advanced biofuel companies in North America, and then we collected and compiled the cost data for 10 companies, as Adam mentioned. And also we contributed to the feedstock cost and availability, and also to the biofuel policy support for this project.
Okay, thank you, Mahmoud. So let's go through the number of questions that we have here. I suggest that I go one by one. I start at the top, and maybe some topics will come back, but we'll see about it. So first question we have here is the biomass that we considered. So you start from certain types of biomass, but do you consider forest residues or mill residues or agricultural residues? So what's the background?
So Adam, did you want to mention that, or do you want Mahmoud to cover, since he was covering
Well,
some?
I'll introduce briefly, and then other people can join in if you want. We looked at a full range of feedstock types depending on the technologies. So this includes wood-based materials, forestry-based products, agricultural residues, particularly for cellulosic ethanol. So we looked at a broad range of potential feedstocks. We divided things into two categories, really. We first of all, we looked at biomass feedstocks, which includes all the things I've just mentioned, where we took a price band that we thought was representative of a range of different prices for those biomass-based feedstocks. We then also looked at waste-based products, meaning municipal solid waste and products made from that, where actually the costs are very low or even negative. And for those, we took a price range from 0 to minus something. I've got the number in my head, as the potential range of much lower costs. So we looked at those two broad categories, but within those there was a range of different materials. In order to be able to do the analysis, we had to rationalize that a little bit, just to come up with some cost ranges which we could apply more generally.
Okay, I think that's quite clear. Going to the next question I have here on my list. Have you considered different risk profiles between different technologies? You know, I can imagine that there's differences between lignocellulosic ethanol or Fischer-Tropsch liquids. Or did you apply the same WACC, WACC across the technologies? I think it was cost-related WACC, but
yes, we did. We just applied the same default financing terms across all the technologies. You can see a little bit some difference between the technologies in the scope there is for cost reduction. So in the cellulosic ethanol case, for example, the costs, because that's earlier in its life, really, the scope for cost reduction there is higher. But we didn't specifically make allowance for that in terms of different financing regime for different technologies.
Ingvar here, I think it's a very important question, and of course in technologies which are less mature there is more reduction potential, while if you go to gasification based systems where you use more or less commercial units in some of the steps, then the reduction potential is less. So it has to be answered in a kind of case by case basis, I would say.
Okay, thanks. There's a question here about anaerobic digestion. Did you look into that, or did you take that as a comparison?
Ingvar here, you could say we took it more as a comparison because it's well-known technology and it's a lot of data out there, and we just wanted to show the big difference in low and high cost, because sometimes you get the feedstock for free, and in other cases you pay for it. So it's a wide span, with some of the production being quite low in production cost.
Okay, thanks. I think that's clear. There was, in terms of technologies, there was some question about 1.5 generation 1.5 cellulosic ethanol. Maybe Jack or Mahmoud, can you explain that?
Mahmoud, do you want to have a chance to answer?
Yes, so actually one of the good quality data we got was from two companies in US. So they actually provided detailed capital operating costs from their facility, and they actually have demonstration and also pre-commercial facility So those data that actually Adam shown in some of his graphs are coming from those two companies.
Yeah, but can you give it, well, what do you consider as 1.5 generation? Maybe not everybody's aware of that. Yeah.
So yeah, this is basically coming from the corn fiber. So you know that in the ethanol production process, you get a byproduct, which is the corn kernel fiber, so that you can actually process that fiber and then produce 1.5 cellulosic ethanol. So it's not coming from corn as sober, it's coming out from the byproduct of the ethanol production.
Okay.
Yeah, so I've had a look. I mean, the feedstock is cellulosic, but there's also starch in there. I mean, if you look at the corn fiber, so the volumes are not as big as we would like, but I think it's a successful transition where you are breaking the cellulose down to sugar and fermenting it.
Okay.
I think these market opportunities are quite important. If you've actually got the opportunity to add some advanced biofuels production to an existing industrial process, particularly a fuels process, then you do get some important economies of scale, and you can share some of the equipment and so on and so forth. So I think it's very interesting to identify some of these integration opportunities, which probably provide some early market opportunities for the technology.
Okay, thank you. Another question here, going back to the biomass type, but also the influence of the biomass type on the capital cost. So I guess capital cost and pretreatment needs for a certain biomass will have an impact on the capital cost. Has this been taken into account?
Yes, I think it was when we, I mean, what we did, we asked the companies we were working with to give us examples of what fuels they were using, what the costs of the fuels were, and then their capital and operating costs. So I think and what we ended up with, as you saw from what I presented, we ended up with quite broad ranges, and I think that represents exactly this, that depending exactly on what the fuel is, that can significantly influence the whole capital cost, particularly the pre-processing cost, and also the efficiency with which you can use the material. So I think that's one of the reasons we've ended up with quite a broad spread of costs.
Yeah. Okay. Another question, which is also related to biomass. I think it's quite important. So you consider the biomass feedstock cost to be constant towards the future. Yeah, is this really compatible if you see a large deployment of biofuels and a large demand of biomass? So how does that play with each other?
Well, we looked, I mean, at a number of studies which have been done on biomass availability and costs, and we've summarised those in the report. We summarised what was in the IEA's Bioenergy Roadmap stuff I did in 2017, but we also looked at, for example, the US study, the billion-ton study in the US. We looked at the work on the availability and costs of biomass in the EU, and so on and so forth. Now, these studies seem to indicate that there's a lot of potential material around, and secondly, that it could be, most of it could be made available within the price bands that we used in the study. So they give I think they give a rather rosy picture. My experience of being engaged in various projects is that in principle there's a lot of cheap material out there, but when you actually go into the market and try and procure it, then it's not as easy as that. So it's I think that's maybe a bit of a rosy picture, but that was the best assumption we could come up with for the moment. I think it's a very complex issue to really look at, I think you really have to do it on a plant by plant basis really to see what your procurement opportunities are and what your cost bases are. I imagine, I think, and I think you can already see this, that actually areas where there are large quantities of low cost material will be the areas that in which these plants end up being built. I think this is what will drive where deployment takes place in the longer term.
I think it's worthwhile mentioning that countries like in Northern Europe, where we use a lot of biomass, both in pulp industry and as in municipal plants, the biomass cost does not go up. Actually, it's a lot of material out there, and I think it's a good way to have that attitude to start the activity, because and then you will see down the line how actually things will develop. This question has a tendency to be a blocker when we discuss to start launching new technologies, that there is not sufficiently amounts of biomass available. And maybe not, there isn't, but there is a lot available. So don't block the issue, so to say.
Okay.
I think it's true that at the moment, it's not because there isn't enough material that these technologies aren't taking off. It's there are places where there's plenty of material to go at, which can be available at a reasonable price and which don't lead to other sustainability issues. If you start getting up to the levels of deployment in the IEA roadmap and beyond that, then that may be a different kettle of fish. But I think at the moment this isn't the barrier to deployment. We should. If we want to see these technologies, we should get on and deploy them, and later on we'll learn really what the limit to exploitation is. But it's almost impossible to judge that on paper, I think.
Yeah. Okay. Thanks. Going to the next question. Well, they're popping up in my screen. It's not so easy to go over them. One question here. It's more practical. So do we share data of capex and opex? I think they are in the actually the magnitudes are in the report, aren't they?
In the report, and you can also, I would say, glance back into the SGAB report. Maybe some more data there, but the updated values are definitely in the new report. And if you need more background, you need to get back to us.
Yeah. Okay, and the report is also available on the IEA Bioenergy website. Go to a next question. Well, there's a question here about pre-treatment. I think we covered that already. So let's see. This one we covered also. There's another question on 1.5. I have to go through the different questions. Another question, which retreatment technology is cost effective for cellulosic ethanol? Do you have some indication on that?
That was not so easy to answer, I must say, depending on type of feedstock and so on. So I don't think we can directly answer that. You need to be more specific. But the data we have received from various parties, of course, it includes their way of pretreatment of their specific feedstock. So sorry not to be able to answer more than that.
Yeah, okay, thanks.
Yeah, this is Jack. If I can contribute, I think our experience is, it needs to be some form of low cost pretreatment. So if we look at the cellulosic ethanol plants that are out there just now, whether it's Clarion or the work that DSM Port or what's going on in Brazil, it's some form of, steam pretreatment. I think as soon as you get into other ones, the costs like ionic liquids tends to get more expensive. So I totally agree with Ingvar that it's very substrate specific. But the method that is most commonly used or trying to be commercialized is some form of low pressure or higher pressure steam pretreatment. But it's very feedstock specific.
Okay, thanks. I got a question here. If the costs are related to the EU market or are more market specific?
The costs we put in the report are based on information we got both from people based in the EU and in the US and elsewhere around the world. So the costs are not geographically specific. They cover the range of costs between different places. I think we did look at costs in from a number of places. I think when we looked at that in a bit more detail, Ingvar will probably be able to speak more about this. But actually, there weren't very significant costs between the different regions, as far as I remember. Is that right, Ingvar?
Yes, I would say so. I mean, it's no doubt that if you go to Brazil and southern US, you can be in the low range, like in our units, then 50 or even lower than 50 euros per megawatt hour, which means 50 euros per ton roughly. While if you are in Europe, you would quite easily end up at 100 or even higher than 100 euro per ton. So that's the span you see in the report. 10 to 20 euro per megawatt hour typically, and even cheaper in the Brazil, for example.
Mm-hmm. Okay.
Yeah, I think the feedstock costs were quite different, but the capital and operating costs were very similar in different regions from what I remember.
Yeah. I have a few questions here on co-processing of bio oil. On standalone versus co-processing of bio oil, and why is the capex for bio oil co-processing so high? So why doesn't co-processing more favorable?
Okay, Lars here. I can try to answer this question. I think one thing is that between the SCAB report and this report, there was an error in the SCAB report, which was corrected. And the reason why the capital cost for co-processing is so high is that the only real information at the larger scale was from an FCC unit in Brazil. And the conclusion was that it was kind of 30% of the bio oil carbon only ending up as biofuel products. So this was causing a fairly high cost, both capital cost and also feedstock element on the capital, on the cost estimate. And we recently also have a discussion with one of the developers of these fast pyrolysis technology, and there's really insufficient data. There's some indications that the 30% in these studies were conservative and could go higher, but there's really insufficient data to say what the conversion in co-processing to biofuels is, since you have several products starting from coke, and then you have gaseous fractions and then liquid fractions, which are the biofuel fraction. And the distribution of your pyrolysis oil, once you put it in at the rate of 5 to 10% together with fossil fuels into a large scale unit and try to measure it, you will have several problems with actually establishing where the biogenic carbon goes. So the numbers are high, but I think there will be new information on this in the coming years that may affect these numbers.
Okay, thanks, Lars. Yeah.
There's also how you value the co-products in this case, whether it's something that goes into the refinery fuel gas line, or if you can sort of capitalize on a small fraction of LPG, for instance, and selling it as green LPG. This was not considered in this estimate.
Mm-hmm. Yeah, I think there is a call for more information, maybe more research also into this co-processing. I think it's an interesting item, but a lot of uncertainties, I guess, still at the moment. And I think our task 39 is also doing quite a lot of work on that. Then I have a next question. What are the main technical challenges for biomass gasification, and mainly for sugarcane residues?
Well, Lars again, and I have also background in gasification and also working with sugarcane residues. And I think in terms of comparing to forestry wastes, I think it's more like agricultural waste, and it does have some ash issues, not as bad as maybe other fuels, in particular bagasse. In the process of milling the sugarcane, you remove or leach out all the alkalis or water-soluble alkalis. But often you're also considering the cane trash, which is a kind of very significant fuel resource if you bring it into the mill. So there's basically not much difference from other biomass. It goes in between forestry biomass and agricultural biomass, like straw, for instance, wheat straw or something like that.
Okay, thanks, thanks, Lars. Another question here I have, it's more about carbon neutrality. Probably that's more another topic. So today is more a topic of cost, but of course it links with CO2 prices and CO2 reductions, of course. Another question was about, yeah, what plant capacities were you assuming for the technologies when you looked into the price?
I can start to answer there. When you're on cellulosic ethanol, we use the numbers and the size of plants which you have seen out there up till this day, which is in the order of 40 to 60 million cubic meters. I like to talk about cubic meters and not liters. 40 to 60 thousand cubic meters per year, and we understand that to be a kind of a normal commercial size. So that goes with cellulosic ethanol. When you go to gasification, Lars should answer in a way, but then we normally see plant sizes being, let's say, at least double that size, 2 to 3 times that size. That has to do, of course, with technology complexity and so on. But we claim that is kind of reasonable.
Okay, thank you.
Okay, Lars here again. Yes, and in the work I tried to scale it to 200 megawatt thermal to sort of compare different technologies. There was also a question of the size of anaerobic digestion, and for biomethane, I think you would be in the range of 5 megawatt to maybe 10, 15, 20 megawatt output to consider biomethane upgrading. If you have smaller plants, the cost would be excessive.
Yeah.
I would like to add an important observation. It was one question about cellulosic ethanol production cost versus methanol, for example. And when we compare these different technologies, the conversion efficiency becomes extremely important. And if you then start with a biomass and convert it to cellulosic ethanol with maybe even less than 30% thermal efficiency, or around 30, that means that a lot of feedstock is treated in that plant, and there is a lot of non-product energy coming out. While if you gasify, you have between 60 and 65% thermal efficiency to methanol. So that means that the treatment of feedstock is half to get a certain amount of product, or the same amount of product for the two technologies. So that has a real impact on feedstock handling and feedstock availability.
Yep. Okay, there's so many questions, so we'll have to be selective a little bit. I think in relation to the capacity, there's also a remark here on India. So India is investing in several plants of 100, I guess 100,000 cubic meter per, oh no, it's 100,000 liters per day. Due to pollution problems and government which is demanding to invest in that. Do you have an opinion on this type of support or yeah, the background of this evolution in India? Maybe Jack or Mahmoud have an opinion there.
Yeah, so look, I think my my own sense with this just now is, as my colleagues know, is that I think we've got to price carbon. I mean, even before the plummeting prices with oil in the last month or so, I think the challenge will be that fossil fuels will remain cheaper. So my sense is I'm obviously a very strong advocate for some of the policies like the low carbon fuel standard, because I think it's technology agnostic. So yeah, I think in India or China, we have to cost carbon. And I think, you know, unfortunately, we're seeing the benefit of the economic downturn in the last little while, just looking at carbon and air quality going up. So my own sense with this stuff is a policy that seems to work using the California and the British Columbia model is to price carbon emissions. So that's the policy I'm a big advocate for. Mahmoud, what do you think?
Yeah, absolutely. So again, if you do a comparison between different countries, you see that California has been attracting most of the biofuels from different parts of the world. So it means that it's working quite great in terms of creating a solid market for different biofuels. So, and as Jack mentioned, it's fuel agnostic, it's feedstock agnostic. So as long as you show that you're reducing the carbon intensity of biofuel, you have a market in California. So I guess that's the advantage of having low carbon fuel as standard.
One last comment. I think the problem, Luke, is it raises the issue of measuring carbon intensity. I mean, that's going to be an interesting ongoing issue all the way from the sustainability of the crop or the residue right through to the processes making the fuel. So I think increasing focus on how we measure or quantify carbon intensity, I think the report does a good job of highlighting that's something we need to continue to look at.
I would also like to comment the incentives in California. I just did a check here on the second last graph, which Adam showed, talking about $3.5 per gallon of ethanol. That actually corresponds to 140 euro per megawatt hour, which you see in all these diagrams. So it's in a very expensive ethanol they are willing to take in California. With that kind of, I tell you that with that kind of incentive in Sweden, we would build a lot of plants.
I think another thing to be thought about, another point which the Indian example highlights is that while no doubt the greenhouse gas reduction is the major policy driver for these technologies, in India there are other parallel drivers which are about reducing oil imports and also about economic activities for the rural people who actually have access to the potential feedstock. So the carbon issue is certainly an important issue, but it's not the only one. And I think that certainly for India, there are these other very strong drivers which also play a role. And I think that's why they're giving such high priority to this opportunity.
Yep. I have a few questions which are related to also this. A number of them are about developing worlds. So is advanced biofuels the technology that can be picked up in the developing worlds? Isn't it better sometimes to go where the feedstock is, because the feedstocks are more in developing worlds? So how do you see that?
I think, as I said when I was speaking, I think in the long run, these technologies will tend to be sited where you've got access to large quantities of available feedstock. It makes more sense to put the plants close to where the feedstock is, and then, if necessary, transport the biofuel rather than actually transporting the raw material. So I think in the long run, wherever you've got access to large pools of biomass resource, that will become an asset and a resource and will attract activity. I think you've also got to think about what the right moment to do that is, and I think that it's probably better to wait until these technologies are a bit mature and a bit less risky and better understood, and then to exploit them in that way. I mean, that's what's happened with wind power and solar power and other things. They were developed in more developed economies, but now are being very widely used in economies which are very rich in wind and sun. I think the same pattern might happen here, but I think the major barrier to development, I think, is the fact that actually several of these technologies have yet to prove that they can really meet their efficiency and reliability targets at scale. And I think maybe it's better for some developing countries to wait until these technologies are a bit mature before they jump into large-scale exploitation of them.
Oh, okay, thanks.
So look, if I can add to Adam, I think some of the technologies, though, are relatively mature. So if I look at lipids to HVO or drop-in, I think the developing world is well positioned to actually produce the feedstock because they've got climatic advantages. And I also think as Adam was saying, I think the jobs on the feedstock side, we're going to generate lots of jobs. The big issue there is sustainability. I mean, we know that palm oil is actually in some ways an ideal feedstock if you're going producing renewable diesel or co-processing. The big issue there, of course, is sustainability. How can you assure that this feedstock is sustainably produced? And of course, the issue is not the technology, it's the feedstock cost. So if we can reduce the cost of the feedstock and ensure sustainability, I think that's where the developing world can probably contribute a lot to this ongoing area.
Mm-hmm. Yep. I have a few questions which are related to hydrogen and maybe e-fuels. One is maybe, is hydrogen maybe a competitor in the future? Do you see that? Or maybe e-fuels a competitor? Or do you see combinations like hydrogen combined hydrogen combination in gasification? So what is your expectation in the prospects of those?
Ingvar here. I think the most interesting one in the short medium term is to combine hydrogen with gasification, because then you actually utilize your green carbon to let's say 50% more than if you have a straight biomass gasification based system. The carbon you emit in CO2 from such a plant actually can be reduced to half, which means that you increase utilization considerably of the green carbon atom. So that is definitely a low-hanging fruit if you can make hydrogen sufficiently cheap. And then the next step is, of course, power to X, as we call it.
Mm-hmm. Okay. Maybe in terms of comparing different regions in the world, do you see the same barriers for technology development in North America versus Europe? And what's the critical barriers for technology development or rollout or the deployment? So is it more policy related? Maybe Jack or Mahmoud know more about this?
So just a couple of comments. I guess, again, because I have a feedstock background, I have a bias toward feedstock. I guess feedstock is going to be very critical. Access to the secure supply is very important for these companies to make sure that they are investing millions of dollars in the first plant. So having access to secure and sustainable feedstock, and also the price of feedstock is going to be one of the main barriers for most of these companies. And then, of course, on the capital side, you need to have access to the capital, and also like in the US, you have access to many of these capital companies. They can provide funding for this project. So there are a couple of elements they have to work together. It's not only technical issues. It's come for the feedstock. Of course, policy needs to also have some support, both from technology support and also from the market support. So they all have to work together so we can have a stable biofuel industry in the future.
Okay, thank you. I'm scrolling down some questions here. Can byproducts, production of byproducts like chemicals in biofuel production, can it have an impact on the overall costs? Not sure, Adam,
I think certainly it can. I think co-production of some higher added value products is a good thing. When we were talking to the companies we were in touch with, we thought that they would say that producing a range of maximizing the value of co-products would be an important way of bringing down the costs of the biofuel product, but actually they didn't highlight that as much as we thought they would. But I think it makes sense to me to maximize the value of the outputs you can get, and if you can do that, then that will be beneficial.
Yeah. And as a general comment, you can say that if you have a low conversion efficiency to your product, there is a lot of byproducts available which need a value, like lignin from a cellulosic ethanol plant. So yeah.
So just one comment. So in addition to the price, co-product and byproduct, they are going to impact the carbon intensity of the biofuels. So if you can't find a market for your co-product, you could also reduce your carbon intensity. So you can generate more credits in markets such as low carbon fuel standards.
Well, this has already been quite important in some existing projects where, for example, the lignin has been used as a fuel to generate heat and electricity for the plant, and the electricity part of that in some places has been able to benefit from feed-in tariffs or certificate schemes and so on and so forth. So that has actually played quite an important part in the economics of some of the demonstration level plants already. So I think that will continue. I think the bigger the pallet and the more of the carbon coming into the plant you can end up in valuing rather than the better the economics will be.
Scrolling further, I have a question here which is about the willingness to invest. So with the experience of first generation biofuels, are banks or producers, investors, are they still willing to invest in advanced biofuels? Isn't that an extra burden maybe?
I think the current pattern is this isn't the financiers aren't falling over themselves to rush and put huge piles of money on the table for these technologies, partly because there are some technology uncertainties still. For some of the technologies, there aren't yet that many very successful examples of projects which are working, so that introduces an element of technical risk. And in some markets, there are still considered to be considerable policy uncertainties. I think in Europe, that situation has improved a bit since RED II has been adopted, but I think the project developers and the people who might finance them are still not convinced that provides the long-term certainty about where their income is going to come from that makes this a very low-risk investment. So I think there needs to be some more evolution both on the technical confidence and on the market and policy confidence before this is really this becomes something a lot of people want to invest in. I imagine that things like HVO is now seen as a good investment opportunity because the technology is working left, right, and centre. There seem to be long-term secure markets for the product. I guess there the risk is, are you going to secure a long-term sustainable feedstock supply of material which is sufficiently low carbon and so on and so forth that allows you to operate. But I think it depends a little bit also on the different technologies. But I think it will be some while before these are seen as mature technologies working in mature markets with mature policy arrangements, which is the combination you really need to make these low cost, very attractive investment opportunities.
Okay. Yeah, it's we can't go through all the questions. I think some interesting questions relate to fossil fuel prices. The current situation, of course, is very extraordinary. We can't produce biofuels at negative cost, I guess. But how do you see this evolving? How much do we depend on the evolutions and the jumps that fossil fuel prices are making?
Well, it plays a big role. I talked when I was about the cost gap between conventional fuel prices, and the prices which need to be achieved to make these technologies attractive, and the lower the oil price, the bigger that gap. So, and that gap has either got to be made up by subsidizing the biofuel price, or by putting some tax or whatever on the fossil fuel price. And the bigger that gap, the harder that is politically to make that discussion, I think. So I think it is a factor, and also the fact that oil prices go up and down means that the income stream for these plants is not assured unless there's some mechanism that helps smooth that out. So I think this is a big issue, and I think if you think about going to lower carbon economies, then actually that will have an effect on pushing oil prices lower rather than higher, probably. So if that happens, then the funding gap will just have to be taken up with some sort of support mechanism, either a carbon price or a support. At the end of the day, they become the same thing. And I think gradually moving to a significant carbon price, maybe a carbon price which puts a floor on the value which these fuels can achieve, will be a necessary step to really bring these things into the market. Because if you start thinking about a large-scale advanced biofuels plant today, it's probably 5 years before that gets into operation, and then if you want to run it for 15, 20 years, you're looking a long way ahead. So, and people won't invest unless they can see a nice steady income stream for a fair part of that time. So I think some important policy intervention, which is the equivalent of a significant fossil fuel price, will be needed. But it won't only be needed for these technologies, it will be needed for a whole raft of things that we want, a whole raft of technologies that we'll need if we're actually going to move into a low carbon economy.
Okay. I think this is a nice closure. I think I'm getting some complaints of people saying, well, you're way past the hour. So I think it's been a nice discussion, nice Q&A. I think there's about 100 more questions here, so it's we don't have really time to go through them. But I suggest that we close it here. I think if there's urgent questions, we still can be reached through the website, I believe. But for the rest, I'd like to thank Adam as a speaker and presentation, and all the others also in the Q&A part. And I give the word back to Chiara, I believe.
Thanks, Luc.
Thank you, Luc. Thank you, everybody. And thank you all for your great participation. The presentation and recording of the webinar will be available from tomorrow on IEA Bioenergy website. I would also like to remind you about next webinars. We will have one webinar on the 20th of May, where we will present the new IEA Bioenergy's logo and website, and another webinar on the 16th of June, about bioenergy combined with carbon capture and storage. So I hope you all appreciated today's webinar, and thank you again, and have a nice day. Bye-bye.